This instructional video is intended for AP Physics C and introduces the laboratory exercise called the physical pendulum. You will write this up as a formal laboratory report worth 35 points. What we're going to do is the following. We're going to verify that the angular frequency of a physical pendulum is this. Okay, so here's the purpose. We're going to verify that the angular frequency omega of a physical pendulum is the square root of mgr over I, the rotational inertia. Okay, you're going to use an ordinary masking tape roll that you could obtain from home in order to do this laboratory exercise. You do, however, need to make sure that most of the tape has already been used, such that then we can think of this as a hoop. So we're going to consider this as a hoop that is then going to oscillate as a physical pendulum. Okay, now when we get to the physical pendulum portion of the laboratory exercise, here's how you're going to set this into oscillation. You first of all need to have some sort of sturdy attachment, as I'm using here with my clamped ring stand, and then I tie a length of string to it like so. Okay, and then I'm going to arrange the tape roll like this, such that when I hold the string horizontally and taut, the tape roll then, for example, oscillates like so. And then you do want to, in fact, make sure that the string here is really taut, so then therefore you just have an oscillation and not a wobble associated with the tape roll. So suffice it to say, the roll of tape is going to oscillate about an axis like this. We're using string in this case. Okay, now there is going to be a little bit of theory here behind the exercise. Okay, when we do get to the oscillations in just a few moments, of course, you're going to measure the period with a stopwatch. So let's go ahead and write the period here, capital T, as 2 pi over omega. That's equal to 2 pi multiplied by the square root of I over mgr. Here's how I'm going to have you ultimately verify the purpose of this experiment. I'm basically going to have you measure I, the rotational inertia, 2 different ways, and then compare them to each other. So let me now go ahead and take you through the procedure. Okay, I divide the procedure here into 2 parts. The first thing to do is measure the rotational inertia of the tape directly. Okay, we're going to refer to this as I measured. Okay, now how do we directly determine the rotational inertia? Well, we're going to take a hoop and then once again place the axis like so, such that it will eventually oscillate like this. So then therefore we're going to use parallel axis theorem to calculate what I refer to here as I measured. Okay, so I measured using parallel axis theorem is going to be ICM plus mh squared. Okay, recall that ICM for a hoop is mr squared, and obviously the value of h, the distance from the axis passing through the center of mass to this new axis up here like so, is just equal to the radius then of the hoop. So I'm going to rewrite this then as mr squared plus mr squared, which is equal to 2mr squared. So then therefore you basically need to measure 2 things. The first thing that you need to measure is you need to measure the mass of the tape roll. I highly suggest that you use a small scale at home, like a digital scale, for example, that you might use for cooking purposes or for postage or something like that. Use a scale at home to measure the mass of the tape roll and make the measurement in terms of kilograms. Okay, so measure M in terms of kilograms. And then the second thing that we need, of course, is the radius. So to obtain the radius, then you're going to need a ruler. Let me go ahead and grab one. And then obviously what I'm going to do is I'm going to hold the ruler directly across the entire tape roll from the outer wall to the outer wall, like so. And then if I pass the ruler through the center, I can then measure the diameter. Divide that by 2, of course, to measure the radius. Write the radius in terms of meters. Okay, so measure R in terms of meters. And then once you do, then you just go ahead and plug everything in and calculate I measured. Okay, this is the first part of the procedure. The second part of the procedure now is to actually set the tape roll into oscillation. So let's call this step 2. So we're going to set the tape roll into oscillation. So do so exactly as I described. You'll have to have some sort of setup at home in order for you to actually anchor down a length of string, as I've done here with my clamped ring stand, and be able to hold it taut horizontally like so. You then take your tape roll, set it onto the string like this, and then you set it into oscillation. Once again, make sure that the string is as taut and as horizontal as possible while you do this. And then with a stopwatch on your smartphone, measure the time necessary for 5 oscillations and make sure that you count the oscillations carefully. Don't accidentally measure the time for 4 or 6 oscillations. So then, measure, we'll call small t, for 5 oscillations. And then therefore big T, the period, is equal to that time divided by 5. Okay, now let's jump back up here to the top board for just a moment. Okay, well, you just measured the period with a stopwatch, and then over here on the right-hand side of the expression, you already have the mass M, and then we have right here the moment arm R. The moment arm R, of course, goes from the center of mass to the pivot itself. That's just equal to the radius of the hoop. So let me do a little bit of erasing here. So now what we're going to do is we're going to set the period capital T equal to 2 pi times the square root of then I, we'll call it theory, divided by mg times capital R. What you then do is just calculate I theory. Okay, make sure, of course, that when you do calculate the rotational inertia for both I measured and I theory, that you include the units. So there's no graph to construct here or anything like that. This is a pretty simple and straightforward laboratory exercise. The last step here is just to compare the two values of I to each other with a percent error. So what we'll do with our percent error is we'll calculate, first of all, the absolute value of the difference between I theory and I measured. And then we'll make the comparison with respect to I theory. Actually, no, excuse me, with respect to I measured, because that's our direct measurement. Like so. We'll then multiply by 100, of course, in order to convert it into a percentage. If you're careful, you should obtain very good results for this experiment, but do make sure that you use a thin tape roll as I'm doing here so we can consider it a hoop. So most of the tape has to be missing. In other words, the thickness here of the tape roll like so is small compared to the overall radius of the hoop. So you do have to ensure that most of the tape is missing from your tape roll, okay?